Hello everyone. So in this course we are going to learn about DevOps and we are going to cover all about DevOps, how it is comes into the picture in the IT world and how you can master DevOps, what you need to learn, what does it includes and everything else. Okay? So let's move ahead and let's see what's in this course for you. Now, first you will learn about what is DevOps and why you hear about this term so much in your IT world. Then we will learn about traditional versus DevOps. What are the differences? Did we need to adopt this DevOps? Then we will learn about what is the history, where did it came from, then its goals, and then benefits, what benefits that is provide, and the real life world example of DevOps. Okay. In the next, we will learn about how you can build your own career in DevOps. What tools do you need to learn? Okay. In the next, you will learn about DevOps lifecycle and DevOps phases and 7 C's of DevOps. Okay, so continuous integration, continuous delivery, continuous testing, continuous monitoring, continuous feedback, and continuous operation. Okay, so you will learn about all of these things. In the next, you will learn about some common DevOps term and with with the tools used. So you will learn about version controlling, build automation, CI/CD pipeline, infrastructure as code, configuration management, virtualization, then containerization, orchestration, monitoring, and microservices. Along with their tools, what tools is used with them. In the next, you will learn about whether DevOps and cloud are really best friends, and you will also learn with the help of example of Microsoft Azure, AWS, and Google Cloud, which are the leading cloud technologies. Okay, and then you will learn about some important terminology in one-line sentences used in DevOps. So basically, it will help you to master your DevOps interview. Okay, so let's meet in the next lecture and let's start your journey with DevOps. Hi friends, welcome to the first lecture of this series. In this lecture, we will learn about DevOps, what it is, how it works, and how it is different from other methodologies. Okay, so if you are working in an IT world or if you are in college, you definitely must have heard about this term DevOps, right? So, what it is, how it works, where it is used. So, we will learn about all of these things here. Okay. So, basically, if you will talk about this term, so it basically came from two words and they are combined together, right? So first one is development and we have taken DEV from it, and then we have operations when we are taking OPS from it. Okay, now in here we are combining both of them. That means it's showing you that hey, there is something in this term or in this methodologies or in this practice which will be indicating that dev and ops are combined together. Okay, so let's understand with the help of an traditional method what was the traditional method for delivering any product, and also we'll see how it is different from DevOps. Okay, so let's move ahead. So let's understand the traditional method for deploying any product so or delivering any product. So how it works, so earlier there were two teams, development and operations. In development there will be different kind of teams, so suppose there is a code team, then there is a build team, and there is a test team, right? They are working on their own and there are no communication between them. They are providing just here and there their code, their result, and then it will be deployed. Now on the other side we have an operations team. So operations team include like a operation manager who is indicating or guiding the operations teams to work on the everything else. Now in the operations it can include an operation engineer to manage or maintain our infrastructure whatever they are responsible for, and other also we can have a database administrators. Okay, now of course there could be many operations team and many development team based on the requirement of the product, right? Now in the traditional method there was a bridge gap between them and there was a wall between them, right? Now, so they cannot communicate between them directly and they have to schedule a meeting for deploying the code or deploying the product. Okay. Now, here we have a release manager who is responsible for uh, understanding what does the product provide and how it is going to provide the code to operations or from operations to development if find any difficulties or if the code is not working as expected, right? Then the release manager expected to whether this product is a release candidate for operations team or whether it could be released or not. And then the operations team work on that and then it introduce to development team that hey, it is an outage alert and whether it needs to be redeployed or redevelopment or retested, right? So that was the traditional method where on development team and operations team are working individually, and also there is many gaps between these internal teams also, right? Now let's understand with the help of example of DevOps. So what is this? So in here, the dev and ops team is kind of one team. There are a development team and then there will be an operations team. They work together in this practice. Basically, DevOps can be referred as a practice or a methodologies for deploying any product. Now, the first phase is plan. So what needs to be done, how we are going to deploy a product. First, it is being planned. Now it is planned by basically professionals or
First,
the phase is plan. Then the next phase is code, which is comes under the development team, but here they are worked with as a same team. Now the next phase will be build. Here the code is built and run with the test case and then pass to the test phase, right? And then it will be released to operations team which are working with development team continuous, and then after the releasing of the product it will be go to deployment phase. Okay. Now after deploying it will be go to the operational phase, whether how many infrastructure it is going to be deployed, and then it will be a monitor. Okay. And after monitoring whether it is working as expected or not, whether it is giving any good feedback or not, then if it is not, then it will be again go to the same phases like plan, then code, then build, then test, and then release. So this makes an infinite circle which is referred as a continuous terms. So DevOps and word continuous is related to each other and they are used with each other. Whatever the phase in the DevOps, so they are continuous. They are built regularly in a sprint to provide an good and quality product. Okay, so let's move forward and let's understand the theoretical definition of DevOps. Okay, now DevOps is a practice. So basically, this is not a software or a tool. So yeah, you can refer the DevOps as a set of tools, but it is not a tool or it is not a software. So you can refer DevOps is a practice that enables a single team to handle the whole application lifecycle. Okay. So unlike traditional methods, so there is no development team and there is no operations team which are working on their own. So we include the development and operation team as a single team so that they work. So basically they include development, testing, release, deployment, operations, display, and planning. Okay. And as we have already discussed it, so it is a mix of term. Dev means development and ops means operations, right? So DevOps is the combination of cultural philosophies, practices, and tools that increase an organization ability to deliver application and services at high velocity. So we are following a continuous approach, but it also does not need that hey, it's providing a bad product or in slow velocity. No, it will provide in means it will be the speed in and also it will be a good quality product, evolving and improving product at a faster pace than organization using traditional software or methods, right? So basically this speed that we are working with DevOps, which fasten our process for deploying the product. So it enables the organization to better serve their customer and compete more efficiently in the market. Okay, so I'm hoping you are clear with the term DevOps, how it is different from traditional methodologies. Okay, now in the next lecture, let's learn about traditional versus DevOps. What are the key differences between them? How they are different from each other? Why did we need to adopt DevOps over traditional? Okay, so that's it for this lecture. In the next lecture, we will learn about traditional versus DevOps. Till then, take care. Hi friends, now we have some info about term DevOps, and also with the help of an example or diagram we have seen how it is different from traditional, right? Now let's understand the key differences between these two methodologies. Okay, now we have seen this. So in the traditional method, so there are different development team and operations team, they are working individually, and also within this team, there are sub teams and they are also working individually. There are no communication between them unless or until it is required, right? So between these, there is a release manager which works as a gate or a wall, and then they decide that whether it is a release candidate for operations team or not, and then it is released. Or if something is happens, then the operations team gives feedback to development team that hey, you need to redeploy it or redevelop it, right? Then it is again go with the code team, then build team, then test team. Okay, now in the DevOps what it happens, so basically the dev and ops team are working as a same team. The first is it is planned by some professional, then it is being coded, then it is build continuously, then it is being tested, then it is released to a production, then it was deployed, then operate to any infrastructure, and then it is being monitored, and then after monitoring it we provide the feedback to the another team within working as a same team to plan it, code it, build it, so that it makes a continuous feedback or continuous cycle for DevOps, right? Seeing the advantages, so there are many advantages comes into the picture for DevOps, right? So let's discuss about all the differences between traditional and DevOps, and what are the advantages of DevOps over traditionals. So let's go through points by point. Okay, now the landscape of software development has evolved significantly, driven by the need of the speed, collaboration, and efficiency. So every company needs that its product needs to be super fast in, which collaborate in, and also they should be provide an valuable product. Now, basically, the two prominent approaches for this product delivery is one is traditional development model and another one is DevOps approach. So basically, both aims to deliver a high quality product, but they are different in their own scenario. So let's understand with the help of key points. So the first one is development and operations silos versus integrated team, right? So we have seen this in our PPT also. So in traditional approach, so development and team works in silos means they are individuals. Developers focus solely on writing code while operations team handle deployment and infrastructure management. There are the lack of communication and collaboration between these teams often lead to delays, misalignment, and a throw it over the wall mentality. Okay, so whatever it comes, they throw on each other that hey, it's not my mistake, it's your mistake, and it's your mistake. While in DevOps, we have an integrated teams which works closely with the collaboration. Okay, so DevOps integration development and operations into a unified team with shared responsibilities. They all have their own responsibilities. So basically what it happens, so it will result in continuous communication, collaboration, and a culture of shared ownership. So with this help of So issues are identified and resolved more quickly. Now on the second point, so there is a waterfall model for traditional approach. You might have learned it about on your college. So basically, first one is requirement gathering, then design, then development, then testing, and then deployment, right? So if the requirements gathering is not completed, you cannot do design. Okay, and if the design is fully not completed, then you cannot do development and you cannot go to the next phase, so on. So this makes dependable on each other phases, right? While in DevOps we use continuous integration, continuous delivery, and continuous deployment, in which they all works in the cycle in the help of the sprints. Okay, so they basically worked in the, so small coded are pushed and integrated frequently, and they worked on this and they delivered in smaller and incremental updates. Let's move to the next point. So first one is manual process. So everything is manual in the traditional. So from code testing to deployment, so they are time consuming, prone to errors, and difficult to scale. So basically the deployment bottlenecks and inconsistencies often arises while doing it manually. Whether in the DevOps we have automations. Okay, so there are various tools for automation. If you want to do a continuous integration, then you can use the tools like SCM for GitHub, and for continuous building them we have Gradle. You want to continuous deploy them, then you have many tools available for DevOps for automating the builds, right? Now on the fourth point, we have reactive versus proactive incident management. So if happens something, then the traditional approach works on it. Okay, and then whatever happens, so the development team and operation team blame on each other, that hey, it's not my mistake, it's your mistake, and then the other team says hey, it's not mistake. So instead of working on the result or solution, they just start blaming on each other and create a negative impact on a product and delays delivery. While in the DevOps approach, as we are continuous monitoring it, so it is like proactive incident management. Okay, so whatever is going to happen, we know with the help of monitor, and we got some alerting system in place which helps potential issues to be identified early. Okay, so this makes DevOps more advantageous over traditional. Now the next point is rigid versus agile and adaptive. So traditional development is typically rigid with fixed plans and timelines. They often change if there are any emergency setup required for development or deploying the software. Okay, while the DevOps is being done in small sprints. So basically it embraces adaptability, allowing teams to respond swiftly to changes in customer needs or market conditions. So they have a shorter development cycles and continuous feedback loop, which makes development teams can iterate rapidly and adjust their process on the fly, whatever the need for the market. Okay. The next one is delay testing. So once all the phases are complete by waterfall model, then it is processed through a testing. While in the DevOps, testing is integrated early in the development process, known as shift left testing. Okay, so you must be aware of this term, shift left testing. So continuous testing is the term. So whatever the phases in this, you will add a term called continuous. So this ensures that bugs are caught and addressed early, reducing the chances of a defect making it to production. Right? Now, hope we are clear with this point. Now let's move on the next point. So first one is longer feedback loop, and for traditional, so feedback in traditional models is often delayed. So basically how it is delayed, so it is only happening with the help of waterfall models. So once all the product is deployed, then we have a feedback. After all the things, all the overall code is made, created, built, tested, then we have a feedback. while in the DevOps, we have some smaller feedback for a small piece of code. If something needs to be modified after the feedback, then we push them back to development team that, hey, in this piece of code, we have a change. Unless we need to change it for the whole code, unless traditional approach, right? So I am hoping you have learned about the 7 key differences between the traditional and DevOps, and also we have seen with the help of a diagram. So let's move ahead. And in the next lecture, we will learn about evolution of DevOps, how it came in an IT world. Okay. So till then, take care. Hi friends. In the previous lecture, we have seen the key differences between traditional and DevOps method and how DevOps has more advantages than the traditional method. Now we have now let's understand the history of DevOps and also what was the response of this practice DevOps. Okay, so let's understand this. So let's understand the brief history of DevOps and its evolution. So there is a guy called Patrick Debois. So he's this guy. So in 2009 a he was a project manager consultant and as a practitioner, so he founded the DevOps conference in Belgium and it named as DevOps Days. Okay, now on the next later in 2012 Elena Brown created and launched the report called State of DevOps at Puppet Labs, okay, which was a software and IT automation company headquartered in Portland, USA. Okay, so now the next evolution was in 2014, where the State of DevOps annual report showed that the implementation of DevOps is accelerating. And in the same year, Janet Gregory and Elisa Crispin released a book called More Agile Testing, giving new impetus to the emerging concept DevOps. Okay, so the evolution of DevOps was very interesting and it was going to peak and peak on every year or every decade. Okay, and between 2015 to 16, so DevOps adoption increased at the rate of 8%, followed by an increase from 10% in 2017 and 17% in 2018. So basically it is being increased again and again because you can see the product quality is higher than all other methodologies for deploying any software or delivering any software or product. According to the market and markets report, the DevOps market will grow from $3.2 billion in 2018 to $10.31 billion by the end of 2023. Okay, at a CAGR of 24.7%. So DevOps adoption is adopted by many more companies nowadays. Now if you are doing something, if you are working something or working on any technology, that technology or that software that you are using, it's definitely might be adopting DevOps. Okay, so DevOps is everywhere and elsewhere. Okay, now, hope we are clear with the brief history and evolution of the DevOps and how it gained the more adoption by the companies. Now, so that's it for this lecture. In the next lecture, we will learn about what are the goals and benefit of adopting DevOps and why the organization is adopting for DevOps methodologies over traditional. Okay. So, yeah, that's it for this lecture. Let's meet in the next lecture. So, till then, take care. Hi, friends. In the previous lecture, we have seen how the evolution of DevOps was so tremendous and how it was giving more and more good feedback for customer to the new companies. Okay, and it was adapted by more companies. So why it was adapted by more companies? Because definitely might have some benefit, right? So let's understand for those benefits and also let's see the goals of the DevOps. So let's move on benefit first. So first one is smarter work and faster work over hard work. Okay. So basically every company needs a faster release for a production and instead of a slower one, and also the smart work. We don't want that, hey, something needs to be done by a hard work only to give a faster release, right? So we prefer a smart work and fast release over a hard work and slow release, right? So that was the key component. This was the main benefit of DevOps, which includes by continuous doing every phases in smaller sprints and deploying the software or product. Next one is quick resolution of issues. So now the next one is quick resolution of issues. So we are performing everything on a small piece of code at first in the continuous process. So if we find something wrong in that, we can roll back the small piece of code, and as it is small, then we can do the resolution and quickly maintain it to continuous integration than continuous deployment or delivery, right? In the next, we have better collaboration between teams instead of giving blame on others teams or each other. There is a good collaboration between teams so that all the individual team are work together in DevOps. The next benefit is have a fostering innovating mindset. So there are many teams working together. So for finding a quick resolution, we have something called a brainstorming, right? So we do a brainstorming and then we we just collect all the mindset innovative ideas and then we carry out the best results. The next, we have a faster threat detection as we are continuous monitoring our infra or our result. So whatever happens, so we can detect our threat as early as possible by maintaining or creating an alert system in the continuous monitoring. The next one is increased customer satisfaction. So there is nothing than a faster release or quality product. So now it is customer satisfaction that should be value to the customer. Next one is providing the much needed edge. So whatever info that need to be included in the software, so it is included in DevOps. So these are the main 7 points which has a benefit on DevOps. Now let's move ahead and let's understand what is the goal of DevOps. So basically the goal of DevOps is it's ensure effective collaboration between the teams. So there are no individual team working on their own like traditional. Every team has their own shared responsibility and they are continuous collaborating with each other to deploying and managing the code, right? The next goal is to create a scalable infrastructure platform. So whatever in there, if we want to increase it, we can vertical increase it, scale it, or horizontal scale it by the help of infrastructure management. Next one, we have build on demand release capabilities. So if our small code is in our hand and it is ready, so if it needs to be developed or deploy as soon as possible, so we can do that, right? So we can release on demand of the customers. Next one is we have provided faster feedback. So continuous feedback is the term I will use it here for better understanding. So a small piece of code are being tested to a test environment and then whatever the result is provided as a continuous feedback back to the development or ops team that hey, this functionality is working in the code form and this this functionality is working in the infrastructure line. Okay, so I am hoping you are clear with benefits and goals of DevOps. Now let's move ahead and let's meet in the next lecture. Till then, take care. Hi everyone. In the previous lecture, we have learned about benefits and goals of DevOps. So in this lecture, let's learn how those benefits are helping in different industries, right? So whether you are seeing in airlines, banking, government sectors, healthcare, hospitality, insurance, or retail, everywhere DevOps is being used. So in this lecture, let's understand how they are used. So first one is airline. The need of rapid transition to a digital ecosystem is driving every industry to adopt new practices and software tools. The aviation industry, which is a complex sector, has led the transformation for many years. When it comes to DevOps, the airlines industry was among the early adopter. Okay, so the early adopter was one of the airlines, which was Delta Airlines. So it's a top carrier in United States, serving over 300 destinations in 50 plus countries. So basically, it implemented DevOps when the concept began taking shape. Jasmine James, IT manager, DevOps Center of Excellence at Delta Airlines, says the company's DevOps model helped remove the silos between operations and development teams, resulting in continuous integration, improved version control, and a focused approach to business critical needs. Okay, so the airline was one of the early adoption by for the DevOps. Now the next one we have a banking. Now, the banking industry worldwide has been reluctant to approve its legacy system, right? So the banking, so if the DevOps is adopted by banking, so you need to understand that definitely it's secure. That's why it's being adopted by the banking. To maintain a business advantage, forward-looking institutions are increasingly realizing the importance of transforming and taking advantage of the digital disruption. British multinational financial services company Barclays implemented DevOps in 2015 to increase its enterprise-wide agility. And right now, most of the banks are adopting DevOps facilities or DevOps practice on their bank. Okay. Next one we have government sector. So the federal government of the United States is highly active in adopting DevOps. Okay, the Federal Reserve, the US Custom and Border Protection, and the Department of Justice all implementing the DevOps method. If you are working on adapting any adapting any laws, or if you are maintaining any IT sector inside the government agency, it is adopting DevOps. Next one we have healthcare. So whatever database or whatever feature they are being implementing for their system, they are adopting DevOps. So, with a significant number of healthcare enterprises using big data analytics to extract crucial insights. So, DevOps in here is steadily gaining ground in the medical sector and accelerating positive development. While other organizations were exploring the possibility of adopting DevOps, Kaiser Permanente and Oakland-based American Integrated Managed Care Consortium implemented DevOps in 2017 itself. Okay, so these are the real life examples. So next one is hospitality or hotels. So DevOps helps hotel brand cope with changing market dynamics, sorting the time to develop, test, and release new offering. So whether they want to deploy something on their website or they want to bring a new ideas in on their hospitality, so they adapt DevOps. Next one, we have insurance. So insurance companies have also made major advances in adopting the DevOps culture. So most global organization within the insurance industry, for instance, Allianz, implemented DevOps model to offer improved digital customer services. Okay, so if they want to increase improvement of their website, so they will adopt DevOps method or DevOps culture to build or release new version of a software of their website, right? Next one we have retail or shopping. They are vast used of the DevOps model, right? The strategic challenges in the retail industry, such as streamlining operation and optimizing merchandise and marketing, are forcing global retailers to automate their IT processes to make software development and delivery faster and more responsive. So it is no wonder that major retailers are taking the DevOps approach in the developing their organization software. So let's understand with the help of one example. So suppose if there is a site and it wants to deploy a new version of a code. So what it will do, it will not deploy the overall code at a time. So it will take a small code or a small feature inside that software or inside that retail software, and it will first deploy it, then it will test it. Once it is tested, it will release one feature at a time. Then they will release or they will start reading the another feature, and then it will redeploy instead of deploying the whole feature, overall feature at a time. Okay, so that's how the DevOps is adopted in retail industries. So I am hoping we are clear with the real life example in DevOps. So yeah, that's it for this lecture. In the next lecture, we will learn about how you can master your DevOps journey or how you can become a DevOps engineer. So let's meet in the next lecture, which is going to be an interesting one. And yeah, so till then, take care. Hi friends. So in the earlier lecture, you have learned about what are the benefits and goals of DevOps, and also you have seen the real life world example of DevOps, right? So let's understand in this lecture, if you want to build your career in DevOps, what are all the requirement you should have, right? So for becoming a DevOps engineer, so I will talk about India. So in India, the DevOps engineer base package start with around 10 lakh per annum. So if you want to become a DevOps engineer, so you should have a bunch of tools or bunch of skill knowledge acquired. Okay, so let's discuss about those skills and tools. So first one is scripting skills. So you should be aware of some imperative programming languages like Ruby, Perl, Python, or JavaScript. And also you should be aware of declarative languages. And one of the declarative languages is used in DevOps is YAML. Okay, yet another markup language. So if you want to learn about it, I have that course in my playlist. You can go through it. Okay. Now that's it for our scripting skills, and also it includes your bash scripting. So bash scripting is also one of the important skill you should be consider if you want to learn DevOps practice, right? Next one is you should have a decision making skill. So this is a basic skill. It is not only required for DevOps engineer. This is required for every other role out there in IT world. Okay, so DevOps engineer must have an exceptional decision making skills to make quick and confident decision. Okay, so whenever needed, you can take decision individually or a teamwork. So you should be in confident in that. Now, this is why you need to be aware of decision making skill. This is because that the ability to make quick decision can facilitate speedy deployment of a new code and fast development. Okay. Now, the second one is knowledge of infrastructure. Okay, so you should be aware of the knowledge of infrastructure, all the 7 layer of architecture, from starting from application layer to data layer. So you should be aware of all the layer those are coming in between. So DevOps professional must have a deep understanding of various IT infrastructure and platform. So you should be aware of web servers, content management, routers, operating system. So one of the operating system used in DevOps is Linux, and Linux is also not limited to DevOps. So basically, every software developer out there is using Linux. They are not relying on any other operating system like Windows or Mac OS. They are using Linux OS. Okay, and along with it, you should be also aware about data centers, networking, and the cloud infrastructure. Okay, now the cloud infrastructure is very, very big. So whether you are going to learn Azure, AWS, and Google Cloud, you should be aware of that. Now, next one is we should have a collaboration skills. So basically, in DevOps, both IT and software development teams are work together, right? We have understood with the help of diagram. So there should be a collaboration skills between this. So suppose if something went down, you should be aware of how you can communicate, how you can collaborate with each other team, and how you can become a successful in DevOps field, right? Now, next one we have communication skills. So whether you are working individually on a particular piece of code or if you are working in a team, you should have a better communication skill. You should be aware of all verbal and non-verbal skills including in this. These are also called soft skill, and these collaboration skills and communication skills is not limited to only to DevOps. These are the needed skill in every other line in IT world. Okay, so these two are soft skills, and these are also looked by every employer in an IT world. Now the next and not last is our technical skills. So basically you should be aware of most important tools used in DevOps practice. Okay, so whether you are deploying code, there are 10 or 15 plus tools out there. If you are considering for continuous integration your code, there are 10 plus tools out there, but you don't need to learn about all those tools. So if you are learning about 2 3 tools, that's enough. So suppose if one tool is not working in your infra, or it is having some licensing issue, you can use the other tools. So also, it should not you should not rely on only one tool. So suppose if you are considering continuous integration, you have given a role, you and your team have given a role for continuous integration, so you guys should not rely only on Jenkins. So suppose if it is not going to work, how you are going to provide a result to the customer? So for this you should be aware of another tool like Circle CI or Travis CI. Similarly, for build, you should not be relying only on Maven, you should be relying on uh, Gradle also, right? Similarly, there are various tools if you are looking for cloud. So you can consider for Google Cloud Platform, Amazon Web Services, or Azure. Both all of these three are leading cloud technologies. If you want to manage your infrastructure, you have Ansible Playbook, Terraform. Okay. If you want to containerize your application, you have Docker and Kubernetes. If you want to orchestrate your deployment, you have Docker Compose and Kubernetes. So you name it, the tool, the DevOps tool is have that. Okay, so there are various tool, and we will learn about in category which tools come in which category in which phase. So we'll learn about those things in later in our lectures. Okay, so I am hoping the brief info, if you want to build your career, which skill you should have and what tools you require to learn. Okay, so yeah, that's it for this lecture. In the next lecture we will learn processes or life cycle and also the 7 C's of DevOps, right? So till then, take care. Hi friends, so I am hoping you are clear with the skills that you should have for becoming a DevOps engineer, right? And also I am sure that you are now familiar with the terms DevOps technically, and also how it is different from traditional, and also we have discussed its benefit, goals, and real world example. Okay, now on the overview, so let's understand what are the overview of the phases in DevOps that we should be aware of. Okay, so let's understand. So first one is plan. So plan is like professionals determine the commercial need and gather end user opinion throughout this level. So in this setup, they design a check plan to optimize business impact and produce the intended result. So basically, it is like gathering information, same like an waterfall model. So in this phase and in waterfall model, what is different? So in here, it will be continuous. Okay. So we'll learn about all those things in while we will be learning process in the next lecture. So while the software development lifecycle gathering information is like you are starting all over from the beginning, but it's not starting all over from the beginning. It's just starting one piece of code and then it will take the plan of another piece of code in there. Okay. Now the next one is code. So here the developer subteams comes into the play. So during this point, the code is being developed. To simplify the design process, the developer team deploys lifecycle DevOps tools and extension like Git that assist them in preventing safety problems and bad coding standards. Okay. Next one is we are having build after code writing the code we will definitely need to build it. So after programmers have completed their task, they use tools such as Maven and Gradle to submit the code to the common code source. Okay, so basically they are only limited to Java. If you are using another framework, so you can use different tools. So build phase is like it is dependable on whatever framework you are using. Okay. Next one is having test. So to assure safe software integrity, the product is first delivered to the test platform to execute various sorts of screening, such as user acceptability test, safety testing, integration checking, speed testing, and so on. Okay. Now these tools consist of JUnit, Selenium, etc. Okay, so the JUnit, Selenium, all these tools are having their own advantages and they are used for different purposes. Okay, the next phase should be the release. Okay, so basically at this point the build is prepared to be deployed in the operational environment. Okay, now on the above four, it is like an operational or development phase of our traditional method. Now in here, we are starting our development phase, operational phase in the traditional method, but in DevOps, it is continuous. Okay. So we are combining all these things into a single team. The DevOps department prepares updates or sends several versions to production when the builds satisfy all the checks based on the organizational demands. Okay. Now, once the test is built, it is being passed over to the next sub team, which is working in the same sprint to check if it is a release candidate or not. Right. Next one is deploy. So at this point, infrastructure as code assist in creating the operational infrastructure and subsequently publishes the build using various DevOps lifecycle tools. So they needs to be deployed. So various tools are used for it, like Terraform or Ansible for deploying, and there is something called infrastructure as a code term. So we'll learn about this in later section. Okay, so if you want to, so on the overview, so if you want to deploy something on large scale of infrastructures, so how you can do that, you can use a code. Okay, so if you will see the example of Ansible, you write something called Ansible playbook. Okay, now you write the code, you set up your hosts in there that hey, you should run all these things in these hosts, and once you run that playbook, it will install or run whatever code you have written on all the hosts you have written in there. Okay, so that's called infrastructure as code. We will learn about this in later sections also. Next one is operate. So now you have deployed the code. Now how you can operate it, if you want to scale it, scale down, or scale up, how you can do that. Also, if you want to add some feature on the infrastructure level, so how you can do that. So this phase do that. Next one is monitor. Okay, so once the operational section is done, you should be also monitoring it for the performance or API, right? So whether it is giving the required behavior or not, whether the performance is good or not. Okay, so you will see everything else in the monitor, and also there are various tools available for monitoring. Okay, so I'm hoping you are clear with the overview of DevOps culture phases. So yeah, that's it for this lecture. In the next lecture, we'll learn about 7 C's in DevOps, or we also referred as the phases or process. So basically in here, we have given the term like plan, code, build, test, but in DevOps, actually, we don't use like that. We use a term called continuous in front of everything. Okay, so we have 7 C's in there. Let's understand in the next lecture. Till then, take care. Hi friends. So in the previous lecture, you have seen the phases in DevOps. So there was plan, then you the professional plans for the whatever the product is going to be deployed. Then you have a code. The development team works on that. Then you have a build. Then you test it. Then you release it to deployment. Then you have deployment phase. Then you operate on infrastructure, and then you need to monitor it also after deploying it, right? Now, these were the overview of the terms like plan, code, build, test, right? But in DevOps, they don't use like that. So in every front of them, there is a term called continuous are added to that. Okay, so we will learn about those in this lecture. So in this lecture, we will learn about the 7 C's of DevOps, and also we sometimes call as DevOps processes in lifecycle. Okay, so basically they includes continuous development, continuous deployment, etc., etc. Okay, so let's move ahead and let's learn about that. So DevOps lifecycle is a set of phases that includes DevOps for taking part in development and operation group duties for quicker software program delivery. Now, while we were discussing our DevOps and traditional difference, we have also seen that there is plan phase, then develop phase, then test phase. So they are also included in this only, and they are also the same. We will understand that those also, but in here we have added something called a term called continuous. Okay, so why we are adding continuous in here? So basically all these continuous meaning non-stop. Okay, so every bits of a code is going through all the process again and again, making it sprintable, right? So we will learn about all these things in here. So DevOps follow positive techniques that consist of code building, testing, releasing, deploying, operating, displaying, and planning. Okay, DevOps lifecycle follows a range of phases such as non-stop development, non-stop integration, and non-stop testing, non-stop monitoring, and non-stop feedback. Each segment of the DevOps lifecycle is related to some equipment and applied science to obtain the process. Okay, some of the frequently used tools are open source and are carried out primarily based on commercial enterprises requirement. So we'll learn about these tools while we will be discussing these phases. Okay, so no need to worry about the tools involved in these phases. So yeah, that's it for this lecture. In the next lecture, let's understand the 7 C's in process of the DevOps. Okay, so till then, take care. Hi friends. So in the earlier lecture, we have seen the basic of DevOps lifecycle and also the 7 C's. Now let's understand all the C's in one by one and all the processes one by one. Okay. Now the first one is continuous development. So in continuous development, the code is written in small continuous bits rather than all at once like traditional method, right? So what we had in traditional method we write all the code at once and then move it to the next phase, right? But in here it is not. So whatever priority of the code is required at first, we write it by planning it. So now at till this phase, the continuous till development phase, the planning is done. That which code should be developed first and which code should be developed first. Now the development team is ready and now they are ready to write the code. Okay, so the This one is the main phase or starting phase, which is going to be responsible because all other phase or life cycle is going to depend on this phase only, right? So whatever the developer is going to write a code, it is going to be tested, then built it or deployed into the production, right? Continuous development raises the standard of the code and streamlines the process of repairing flaws, vulnerabilities, and defects. It facilitates the developer's ability to concentrate on creating high quality code. Okay. Now, continuous development is also not deploying every code at once or new code. So basically, if the product is being deployed in the test environment and suppose if nothing is working, so they are bring back to the development team. Okay. So if they are built it, if something find out that hey it's not working, then it is bring to this continuous development phase again. If it is in test phase, if it is find out that hey integration test is not working, then it is all again bring it back to the development team. Or if it is released and if it is not working as expected, then it is also bring back to the development phase. Okay. So the development phase is very important phase in the DevOps lifecycle, and basically all the other phases are dependable on each other. But so basically the continuous development is used for providing a high quality code. So instead of writing all code at once, they are written in small or continuous bits. Okay, so that the smaller sprint can be given a high quality piece of code. Okay, so I'm hoping you are clear with continuous development. Let's learn about continuous testing in the next lecture. Till then, take care. Hi everyone. So in the previous lecture, we have learned about continuous development. So in this lecture, let's understand what is continuous testing when we talk about DevOps lifecycle. Okay. So any firm can deploy continuous testing with the use of Agile and DevOps methodologies. Okay, so you must have heard about the term Agile earlier in your IT world. Depending on our needs, we can perform continuous testing using automating testing tools like as Test Sigma, Selenium, Lambda Test. Okay, there are not limited to these three only. There are various of testing tools available for you on continuous testing. Okay, so with these tools we can test our code and prevent problems and code smells, as well as test more quickly and intelligently. Okay, so whatever the piece of code you are getting from development after the build, it is being tested, right? So suppose so it is also throw and back process. So if you find that this functional testing is not working, then it is bring back to the build phase or development phase. Okay, with the aid of continuous integration, we'll learn about this in the next. Like Jenkins, the entire process can be automated, which is another added benefit. Okay, now this continuous testing is can be also integrated with lifecycle, and the Jenkins is tool which is used for this. Okay, so like Jenkins, there are various tool for these two for integrating or for combining two or more lifecycle at the same time. Okay, now in here if you can see in the diagram, so there is continuous testing illustration. So there are some features the developer had deployed. Then you have a source control, you are pushing or pulling the code whatever the source you require, then you build it after modifying it or changing it. Then you have your unit test, or then after the unit test you will having an integration test for integrating all the result at the same time. Okay, then on the other parallel phase of the testing, you have a code analysis team that will be verifying your code, and this process is to and fro. So if it is going in this way, it will come in backward way also. So suppose if unit work does not work well or integration test does not work well, they will throw the code back to the development team to redeploy it or redevelop it, right? That's what was continuous development. Okay, so yeah, that's it for this lecture. In the next lecture, we'll learn about continuous integration. So it is most asked question in DevOps field. So we'll learn about it. Hi friends. So in the previous lecture, we have learned about continuous testing, although it is on third phase of the life cycle. So basically what happens? So after continuous development, it is go to continuous integration and then it comes to continuous testing. But I wanted to discuss continuous integration, what which is the second life cycle, and continuous development in at the same time. Okay, so that's why I discussed continuous testing earlier than the continuous integration. Okay, so in this lecture, let's understand the continuous integration. Okay, so suppose there are bunch of developer working on their own code and they are working on a single repository they have pulled there, and also the repository is connected to SCM in there, right? Now these developer are writing the code and they are having different set of branches and they are merging them to a single branch. Okay, so they are merging them to the single branch. Now this functionality or this process is called continuous integration. Okay, hope you are clear with this. Now let's understand with the help of theoretical example. So continuous integration is a DevOps software development practice where developers regularly merge their code changes into a single central repository. Okay, after which automated build and test are run. So after continuous integration, continuous testing phase comes into the play. But we have discussed it earlier. Okay. Continuous integration most often refers to the build or integration stage of the software release process and entails both an automation component, example a CI or build service, okay, and a cultural component, example learning to integrate frequently, okay. So whatever the feature they are working on, they are integrating those all of these in the single repository. The key goal of a continuous integration are to find and address bugs quicker, improve software quality, and reduce the time it takes to validate and release new software update. Okay, so how it works? So suppose if there are only one developer and he's working on the code, now it is being deployed. Okay, it is now merged to the single repository. Okay, right? Now the next developer comes and once he will write the code, and suppose if it is conflicting to the single repository, so what it will do, it will create a merge conflict, right? So that will create the issue and it will take time to resolve that conflict. So how it works in there? So at the same time multiple developers are writing the code on the same line or the same different branches, but yeah, of course they are going to merge it to a main branch. So whatever they are writing, they can write the small piece of code on their own and they can merge into the single streamline. If there are any conflicts in there, they will talk to each other and they will resolve it and they will merge that particular feature to the central repository. Okay, so that's how the continuous integration works. So we will learn about these tools also in the later section. So that's it for the continuous integration, CI. In the next lecture we will learn about CD, which is sometimes also referred as a continuous deployment or continuous delivery. Okay, so till then, take care. Hi friends, so in the last lecture or last series of this lecture, we have learned about continuous integration. Now let's learn about another term called CD, which is mostly used with CI or continuous integration, which is called continuous deployment or continuous delivery. Okay, so the continuous deployment is like basically it is a process of automatically deploying an application into the production environment, okay, when it has completed the testing and build stages. Okay, so in here we don't need any further approval from the release manager or operational manager. It's just being deployed. Okay, it's being approved already. It is automate process. right? Now, while the continuous delivery is the process of deploying an application into production servers manually when it has completed the testing and the build stages, right? So when the build stage or testing stage is done, then after there, then even after also there are a final check whether you want to deploy it or not. Okay, so that's the main difference between continuous deployment and continuous delivery. Their results are same. Now in the continuous delivery we will automate the continuous integration process, however the manual involvement is still required for deploying into the production environment, right? So in here, let me take my laser pen. So in here our file is ready with the version. So continuous integration was still here, right? We have the continuous integration till building of the code. Now the source code is automated. Now from build to stage we have automated this stage also, but from staging to production we have two options, whether it can be approved already or whether you need a final checkup. If it is approved already, then it is a continuous deployment. If it is not, if it is a manual intervention, then it is a continuous delivery. Okay, so I am hoping you are clear with the difference of continuous deployment and continuous delivery. Okay, now let's move ahead with another life cycle or the next life cycle in our DevOps phase, which is continuous monitoring. Okay, hi friends. Now after continuous deploying or delivering the product, now you must monitor it also, because you don't know what is going to happen when it is being deployed in the production, right? So you definitely need to monitor it whether it is giving the same performance as expected, or whether all the features are working as expected. Okay, so this phase is the important one. If it is not included, then DevOps lifecycle is incomplete. Now, the continuous monitoring can be achieved with the help of Prometheus and Grafana. So these are most leading tools for continuous monitoring, and can get, basically they have alerting system also. So if something goes wrong, you can be notified with the help of these tools. We can gather many performance measures, including CPU and memory utilization of your servers, which are on which your application is being held. You can also monitor your network traffic, your application response time, error rates, and others. So when we will discuss about continuous monitoring tools, we will learn about various tools used in these different areas. Okay, so this was for Prometheus. If you will talk about Grafana, so Grafana made it possible to visually represent and keep track of data from time series, okay, such as CPU and memory utilization. Okay, now if you want to filter back, if you want to see the logs from different timeline, you can definitely do that with the help of Grafana. Okay, so continuous monitoring is important aspect when you are deploying a high quality of code. Okay, it also comes into maintaining the product. So if you are going to deploy your code, you definitely need monitoring to it. Okay, so that's it for this lecture. Let's meet in the next lecture. Now the next life cycle is continuous feedback. Now feedback is also one of the important aspect for any product. So if you want to deploy a high quality of product, you should have a feedback in place, right? So whether if you are going to place the feedback lifecycle after just after the build, or just after the test, or just after deploying the product, right? So once the application is released into the market, the end user will use the application and they will give us feedback about the performance of the application. Okay, and any glitches affecting the user experience. After getting multiple feedback from the end user, the DevOps team will analyze the feedback given by end user. Okay, and they will reach out to the developer team tries to rectify the mistake they are performing in that piece of the code. By this we can reduce the error of the bugs that which we are currently developing and can produce much more efficient result for the end user. Also, we reduce any unnecessary steps to deploy the application. Okay, so this is very basic to understand of the continuous feedback. So this can be implemented, whether this should be also implemented on every phase. So suppose if you are building the code, you should have a feedback in place of some kind. So I am hoping you are clear with continuous feedback. This is also one of the important player in the DevOps lifecycle. So if you want to build your code, if you want to get feedback, if you want to test the code, if you want to get the feedback, or if it is released to the market, you definitely need to get feedback from the end users. Okay. So in here, the end users feedback requires the most, and that's why you are calling it continuous feedback, because a smaller sprint of the code is now sent to the production, and now end user will test it, or end user will use it and provide the performance, or how the application is working, right? That's it for this lecture. In the next lecture we'll learn about next life cycle. Okay, now we have some continuous feedback in place by the end user. And so now suppose if you want to do, if the users are complaining about not about the code or performance, so how it is done. So now in here continuous operations comes into the play. Now whatever the servers or the code is built on or any server, so that server is scaled up or scaled down based on the requirement or feedback getting from the user, right? So this phase is called continuous operation. So this does not include only scaling up or scaling horizontally or scaling vertically. So basically if you don't need, so basically after monitoring the system or monitoring the your product or application, what happens? So suppose if the RAM utilization or traffic is not going very high, you can minimize the resources and lower the manufacturing cost or lower the operational cost. Okay, so I am hoping you are clear with all the 7 C's or 7 life cycle in the DevOps. Let's meet in the next lecture. So in the next lecture, we will learn about various terms used in DevOps along with their tools. Okay. So till then, take care. Hi friends. So in the previous lectures, we have seen about 7 C's in DevOps. So now let's move ahead and let's see some important terms like CI/CD pipeline, build automation, and version control in the next sections, and also we'll learn about the tools used with them, right? So let's move ahead with version control. Okay, so this is the important one. So in many DevOps interview it is asked. So version control systems are a category of software tools that helps in recording changes made to files by keeping a track of modification done in the code. So they just not keep a track. So if you have some version of a file, you can roll back to that version of a file, right? Now what are the benefits from it? So a complete long-term change history of every file, with which consists of your author's mail, and also the time and date while changing, right? Also the branching and merging, so it not needed that every developer will be working on the same branch, right? So they might be working on different feature and different branch. Now they need to merge it also to the main line. So version control also provide the feature for merging to the same branch. Okay, now if there is any conflict, they will resolve it by talking to each other, and they will consider it to adding it to mainline. Next one is traceability. So basically it keep track of every changes done by which author and when. Okay, So these are the main three benefits of version controlling, and version control is not only used in DevOps, so it is used in every development environment in IT world. Okay. Now, when you will talk about the version controlling system, you have three type of version control system. First one is local version control system. Second one is centralized version control system, and third one is distributed version control system. Okay, among these, they all having on advantages and on disadvantages, but the most of them are used is distributed version control system. Okay, so let's discuss one by one about all these types of version control system. Okay, now let's learn about local version control system. So now in here there will be your in your local version control system there will be your local computer. Okay, in the local computer there will be a version database of your local file. Okay, so there will be, and another side there will be a file which is keeping track of your data or whatever version you are making creating in that file. Okay, now in that version database you will have different versions of your file. Okay, and they are also connected to each other, means if you want to roll back version 1 to version 2, or if you want to upgrade your version 2 to version 3, or suppose if you want to downgrade your version 3 to version 2, so you will have that feature in your local version control system also. Okay, now the file is like your control of your version database. So if you want to track or if you want to roll back to any specific file, you just mention in the file system and it will be rolled back to a specific version. Okay, so that is your local version control system. So the advantage is very fast because it is not relying on any server, and the disadvantage is that it is on your local computer. Okay, now, if you want to deploy any application, so you need to first configure your server integration with your local computer. Okay, so I'm hoping you are clear with local version control system. Now, let's come on your centralized version control system. Okay, so please ignore this one. I think this might be some error with my PPT. Now, so basically there is three workstation. Okay, there are three workstation PC, and on all of these you might be working on a copy of a repository, right? Now there will be also a single repository on your server, so you have a connection like update or commit on each of the working copy to that single repository on a server. Okay, so you have a three copy of a file on which three individual developer are working on it, and all of these three copies are connected to a single repository on a server. Okay, and now you are sending update and commit updates to the server to and fro. Okay, so that's how centralized version control system works. Now the advantage is you can see that it's connected to a server. If you want to deploy, it's ready already. Okay, now the main disadvantage is that there is no intermediate repository between them, right? So what you are doing, you are working on a working copy and then you are directly uploading on a server. Okay, so suppose if server that single server is integrated with some application server, so it is directly pushing them or pulling them. Okay, if you are using automation, now we don't want that. Suppose if any developer worked of code in a mistake and it he pushed or committed the code, so how it went, so it directly pushing to the server. Okay, so that's how centralized version control system sometimes may be referred as advantages and sometimes disadvantages. Okay, now the next one and most advanced is we have a distribution version control system. In here also we have three workstation PC, and there are three working copy of this computer. Okay, now these three working copy of a computer are stored on a three repository, so they might be on your local PC or they might be on a server also. Okay, now the you are doing update commit to these to and from, and now above these repository you have a server repository. Okay, and from the server repository this local repository is being pulled or pushed. Okay, so now the advantage of this, whether you are going to push any wrong commit or pulling any wrong commit, you have an intermediate stage. Okay, Now the disadvantage is that it is bit slower as compared to the centralized or local, but it's more secure and more reliable. Okay, so I am hoping you are clear with localized version control system, centralized version control system, and distributed version control system. Okay, now let's learn about the version controlling tools used in IT world. So first one is Mercurial. So Mercurial is a distributed version control system management tool. So it can handle project of any size and provides a simple interface. Okay, Mercury is easy to learn and they provide an array of guide and overview to ensure you quickly begin getting the most out of the tool. Okay. Now next one you definitely must have heard about it. It's a Git. So it's an also a distributed version control system which is fast and efficient and it can also handle project of any size. Okay, and the it's a icon for Git. You definitely might have heard of it. Next one is Bitbucket. So this is a version control software that support distributed version control and make it easy to collaborate on a code with a team. Okay. Next one is GNU Bazaar. So a free and open source version tool that can track changes made on the file. Okay. So everyone has their own functionality. If you will talk about their functionality. And next one is Subversion. So you might also heard about it with the Git. So it's an also free and open source, but it's a centralized version control tool. Okay. So this is a centralized and these three are distributed. Okay. So I am hoping you are clear with version control tools used in IT world. Now I am hoping you are clear with every aspect of version control system. Now let's meet in the next section with some more keywords used in DevOps along with the tools used with them. Okay, so till then, take care. Hi friends. So in the previous lecture, we have seen what is version control system and what are its type and also the tools used for version controlling system, right? And the most popular tools are Git and Subversion. Okay, you might have also heard about it or you might have used it. Okay, now let's move ahead and let's discuss about other keyword used in DevOps, which is build automation. Okay, so build automation, let me take my laser pen. So build automation is the process of using tools to automate the task involved in converting source code into an executable software. Okay, so basically the developer is writing their code and then as a result they should be create an executable software, right? So for example, if they are writing any Java file or Java code, then it should be create any jar or var file, right? So we have something called a keyword build automation for this task for converting our source code into executable software. Okay, now this executable software is portable, means if you package this jar or war file, they can be given to any other piece of software or integrated with other piece of software for their working. So whenever you will execute the jar or war file, it will work as an application. Okay, now this process includes tasks like code compilation. So for executing software, it will compile the code and then if needed, it will create it to binary form and then it will do any object file conversion also. Okay. Then it will have a dependency resolution. So if you have used Maven, then it has some dependency. Okay. Dependency column in their pom.xml file. So they also resolve their dependency and it is also used for packaging and testing. Okay, so whatever executable software you are getting from it, it can be packaged further. Okay, and also they can be used for a testing. Now in build automation, as we have already discussed, so first it will be triggering a build. The first step will be triggering a build. So whatever code you have written, so whether you can trigger it manually or you can trigger it by setting off any SAS URI. Now the next one is running a build. So after triggering it, you need to run it. and then it will execute your test cases. If it is passed, then you are ready to go further. Then you need to publish the build artifact. So after the executing test or running the build, it will create a build artifact. Okay. And also, if you are using some advanced tools for the build automation, you can get metrics and feedbacks too. Okay. Now, why you need to use build automation? So basically, the name contains automation, right? So it can be automated. Second one is consistency. So you can consist your packaging by this build automation, okay, for the same piece of code. Now, third one is dependency management. So whatever the dependency is there for any piece of code, it will resolve for you. Task parallelism. So at the same time, you can have multiple build at the same time. Okay. Incremental build. So if you are running a piece of code for a build, you can also integrate another piece of code. Okay. Now build automation is used with CI/CD integration. Okay. So basically, but when the developer is writing their code, they need to publish it or build it, then they need to release it, right? Okay. Now the next one, why should you use build automation, is testing and quality assurance. So this does not come in every tool. So some advanced tool have this option for quality assurance and testing. Now the compatible and expandable. So whatever executable file you are getting, it will be compatible and expandable with many devices or many platforms. Okay. And the last is deployment and packaging. Okay. So it will give you the package codes. Okay. So suppose if you are taking Maven, for example, so it will give you the jar or war file after building your automation. Okay. Now let's see about the tools used in this. So basically the build automation tool depends on your programming framework. Okay. Now first one is Gradle. This one is also one popular. So the open source build automation tool Gradle places a premium on adaptability and speed. Okay. It defines build a script with a Groovy based DSL. Okay. So basically it will be on Groovy based domain specific language. Now next one is Maven. So it is also one of the popular. So Apache Maven is a popular build automation tool that was found its niche in Java development. Okay, so basically the programming framework used for Maven is Java. Okay, it controls construction via XML project object model file. Okay, so there is a main file called pom.xml. So basically that is the control file of Maven. Okay. Now next one is Ant. So basically it is old, but it was also the popular for the Java project. Okay. Ant is an build tool primarily used for Java projects. So it is based on XML script and provide basic build automation feature. Okay. So I am hoping you are clear with these three most common build automation tools for build automation. Okay. Now, I'm hoping you are clear with build automation. Let's meet in the next section with the new keyword used in DevOps. Okay, so till then, take care. Hi, friends. So, in the previous lecture, we have seen about build automation and what are the three tools, most common tools that used for the build automation. Okay, now let's move ahead and let's understand the key keyword in DevOps, which is CI/CD pipeline. Okay, so whether if you are preparing for an interview or if you are going to work on a DevOps project, you should be aware of CI/CD pipeline. Okay, so a continuous integration. So we are aware of this term. So what is continuous integration? Continuous integration means multiple developer are integrating their code to a single repository. Okay, then they are triggering it for build and then test, right? And what is continuous deployment? Continuous deployment means the builded code is going to be deployed to a production or released to be production or automatically. Okay, and continuous delivery was there was manual intervention was required for releasing the product. Okay, now a CI/CD pipeline is a series of steps that must be performed in order to deliver a new version of software. Okay, so this is the practice of we are talking about. So the CI/CD is commonly used for DevOps practice for delivering any software or a product. Okay, CI/CD pipelines are a practice focused on improving software delivery throughout the software development lifecycle via automation. Okay, so this is not a traditional SDLC. This is our DevOps because we are going to achieve our SDLC via automation. Okay. Now we have already discussed about this. These are the basic phases. We haven't added continuous in before of that. So first one is plan. So projects requirement features and roadmap, what we are going to cover. Then also the plan cover which piece of code we are going to build first. Now the next phase is code. So write the code according to the plan. Then the build, compile code into a runnable instance or create a executable file and then test. Okay, now this one comes under continuous integration, means we are writing the code, building it and combining it, right? And once it is tested by our testing team, then it is released for our deployment. Okay, and then it is deployed and then it is operated and then it is monitored after that. Okay, now this phase comes under continuous delivery or continuous deployment. Okay, now this whole process makes it CI and CD pipeline. Okay, and this is the core of our DevOps practice. Now by automating CI CD throughout development, testing, production, and monitoring phases of the software development lifecycle, organizations are able to develop high quality code faster and more securely. Okay. Although it's possible to manually execute each of the steps of a CI/CD pipeline, but it will not be called as DevOps. Okay, because DevOps practice is all about automation. Okay, the true value of CI/CD pipelines is realized only through automation. Okay, so I am hoping you are clear with CI/CD pipeline, how it is used in DevOps, and also the all the phases that we have seen here. Okay, now let's move ahead and let's learn about some tools, some famous tools that is used for CI/CD pipeline. Now, first one and most popular is Jenkins. Okay, you might have also heard about it. Jenkins is an open source and cross-platform tools that offer continuous integration and also delivery. Okay, it also supports real-time testing and reporting. Okay, now next one is Circle CI. So it's an also an automation tool that allows user to automate their entire pipeline. Okay, from code creation to testing and deployment. Okay, so this is also an alternative of Jenkins. Next one is we having Travis CI. So basically a tool that allows user to sign up, link their repository, build and test apps. Okay, it integrates with common cloud repositories like GitHub, GitLab and Bitbucket. Okay, now Jenkins also provide our SCM like GitHub, so it also integrates with that. Next one is Team City. So a general purpose tool that integrates with build and test tools. It keeps a history of tests, flags unstable tests, and can help identifying the exact commits that cause failures. Okay, so it's good for monitoring too. Next one is Bamboo, a tool developed by Atlassian that offers deep integration with other Atlassian products like Jira and Confluence. Okay, so I am hoping you are clear with this most popular tool for CI/CD pipelines. Okay, now let's meet in the next lecture with some another keyword used in DevOps. So till then, take care. Hi friends. In the previous chapter, you have learned about CI/CD pipeline and also the tools used for CI/CD pipeline. All right. That was also one of the important keyword or aspect in DevOps practice that is used. Now let's move ahead and in this lecture, let's learn about infrastructure as code. Okay. So this is also one of the important aspect or keyword used in DevOps, and it is also used most of the time in the DevOps interviews. Okay. Now, suppose if you want to deploy a piece of code or package a piece of code on a large number of infrastructure or large number of workstation at the same time. Okay, so how you will do that? So you cannot do that, right? By manually, it's not possible. It might take up to days or weeks. Okay, now, but the client needs it to be deployed as soon as possible. So how you will do that? Okay, now you can do that by infrastructure as code. You will not only deploy the code on those infrastructure or on those workstation, you will deploy them and also you will manage them via your single client or single computer. Okay, which will work as a master. Okay, now let's understand infrastructure as code in detail. So infrastructure as code is a method of managing and provisioning IT infrastructure using code rather than manual configuration. Okay, so you are not doing any manual configuration because if there are large infrastructure working in the background, you won't be able to manage all of that manually. Okay, so you will need some kind of automation or some kind of code to manage all those things at the same time. Okay, it allows teams to automate the setup and management of their infrastructure. Okay, making it more efficient and consistent. This is particularly useful in DevOps environment where teams constantly update and deploy software. Okay, so they want to scale up, scale down. Okay, and if they want to change any configuration, so they can just write or update in the code and they can just run the playbook. If you're using Ansible, so you just run the playbook, it will make the changes on it will make the changes on all the hosts that was mentioned in that playbook. Okay, so we learn about those tools also. Now let's move ahead. So what is a feature of infrastructure as a code? So first one is automation. So there is no point if there are no automation, right? Second one is repeatability. Okay, so it should repeat your code. If there is something happening, you may go through all the code and you may update it. Okay. Third one is version controlling. So you may also integrate with version control system. Scalability, of course, you should use for infrastructure as code scalability problem. Transparency, it will give you all the output or all the things that is going to happen on your whatever provision infra that you have set up. And at last, improve security. Okay. Now next one, what is the application where it is used? So the infrastructure is used in cloud computing and DevOps, CI/CD, networking, web application development, database deployment, or big data analytics. Okay. Now, where you can use infrastructure as code. So there are some example, and these example are not limited to this. There are various example for infrastructure as code. So the common ones are provisioning virtual machine. So if you want to provision lots of virtual machine, you can do that by writing a code. Deploying a network, so you can also do that by infrastructure as code. Setting up a database, deploying a web application, and managing DNS records. Okay, so you can do all of that via infrastructure as code, right? Next one is we are having two types of infrastructure as code thing. So first one is declarative and second one is imperative. Okay, so the declarative approach is specify the desired state of the infrastructure, okay, such as the resources and their configuration. Okay, while the imperative approach details the exact steps or command required to achieve the desired infrastructure state. Okay, now the tools used in as infrastructure as code are categorized with these two approach, declarative and imperative. Now let's discuss about those tools in the next slide. So first one is Terraform. So it is a declarative. If you will talk about declarative, so what it will do, it will desire the state of infrastructure such as resources and configurations. Okay, so you will write the code and you will run it, while the imperative you can do that via commands or CLIs. Okay, now the Terraform, so that's HashiCorp. So it's the parent company is HashiCorp, the widely used open source tool from HashiCorp that automates the management of cloud and on-premise resources. So they are not limited to only cloud. they can manage your on-premise resources also. Okay, so here you will write any file and then you can run it. It will run your deployment. Okay, so this is Terraform. It is one of the popular tool for infrastructure as code. Next one is AWS Cloud Formation. It also uses declarative and it is in AWS environment. Okay, next one is Ansible. So this one is most popular among all of these infrastructure as code tools. Okay, so it is both imperative and declarative. So basically, it's a simple agentless automation tool for managing configuration, provisioning, and deployment. So it does not need any tools to be installed on the client. Okay, you just need your Ansible playbook, mention your host, and run the program. It will do that. You just need to make sure that your client or from where you are running the code, it should be reachable to your destination host. Okay. Next one is Puppet. So it is also one of the popular. It's a configuration management tool. So basically, it is not infrastructure as code, but we have included that because configuration management tool includes infrastructure as code. Okay, so it will do that. So it's an also declarative language, and it is designed for automation with an emphasis on large scale of infrastructure. And next one is chef. So it's an imperative, means you will run a command via CLI and you will do that. So basically it is also a flexible tool that automates infrastructure management using Ruby based domain specific language. Okay, so I'm hoping you are clear with infrastructure as code and their tools used. Okay, now let's meet in the next lecture with configuration management. Till then, take care. Hi friends, in the previous lecture we have seen what is infrastructure as code and also what are the most popular tools used for those. Okay, now in this lecture let's learn about configuration management. So basically infrastructure as a code, it includes in configuration management. Okay, now what is configuration management? So basically if you have some desired state for any IT system or its component, you need configuration management for managing it. Okay, so you don't want any manual intervention on those, and if you want to do that by any automation or by any client host, you can do that using configuration management. Okay, so configuration management is a process for maintaining a desired state of IT system and components. So it helps ensure that a system consistency platform as expected throughout its life cycle. Okay, so the configuration management in DevOps includes various in four form. So they are infrastructure as code, which we have discussed in earlier section. So if you haven't seen that, please go through the that lecture. So in here, a code or script that automates the process of creating a development platform. Okay, this code is pushed to a version control system, which allows to be used to define and update the environment. Okay, whatever infrastructure you are going to be deployed. Next one is version control. So configuration management also includes version control. So what is version control? We have also discussed about it. So you may go through our version control system lecture. So basically it is a tool that allow users to see the history of a system evolution. It can be used to identify when changes were made and how two versions differ. Okay, so now the version control system does not use for code. It also used for your configuration on your infrastructure. Okay, so most of the tools give you that option. Next one is change management. So whatever change or impacts been done on your infra or on your workstation, it will have a track of it. Okay, now the change management is a process that helps manage changes to software and configuration. It includes tools for tracking change requests, accessing impacts, and ensuring that changes are implemented smoothly. Okay, and next component of configuration management is artifact repository. So basically it's a database that store machine file like binaries, test data, and libraries. Okay, and dependencies also. So artifact repository will store that. So basically these are the four component of your configuration management. Okay, now if you will talk about tools, we have discussed about these tools in earlier also. So these are the tools used for configuration management. So version control, you will use Git. For your infrastructure as code, you can use Terraform, Chef, Ansible. Docker is a containerized tool we will talk about when we will be discussing our containerization. Puppet is also one of the configuration management tool, and Salt Stack you can use it also too. Okay, so we have discussed most of these tools in our earlier chapter. Okay, so I am hoping you are clear with configuration management and how it helps in IT system. Okay, now let's meet in the next section with the new keyword used in DevOps. Till then, take care. Hi everyone. In the previous lectures, we have learned about configuration management and infrastructure as code and the tools used for them, right? Now let's move ahead and let's learn about virtualization and containerization. What are those? What happens? And why do we need containerization instead of virtualization, right? So, virtualization and containerization are both computing technologies that allow for the efficient use of hardware resources. Okay, virtualization creates VMs that runs on a single physical server, while containerization allow multiple applications to run on a single VM or server. Okay, so this is the main difference between them. If we will move further, so we will learn about the main differences between the main key point differences between them also. Okay. Now, on the upper hand, if you will talk about the main difference, so suppose you want to run your own VM of different OS. Okay. Now there is an underlying infrastructure of your main operating system or your main laptop or computer, right? Now on to that infrastructure, you have your own operating system, right? Now on that operating system, you want to run multiple operating system or guest OS, right? So you have those guest OS right there. Okay. Now these guest OS will have their own binary file, their own library, their own dependencies, and also they will having include of set of utilities or applications, right? Now for running this VM on your main OS, it will need some kind of software that can manage. Okay, so that's what we call it as hypervisor. Okay, so in Windows, Hyper-V is kind of hypervisor which maintains virtualization and Windows system. Okay, so if you'll talk about the definition, so virtualization is the process of partitioning a physical server into multiple virtual server. Okay, now this is done by your hypervisor. And what is hypervisor? So it's kind of software also known as virtual machine monitor that executes on a computer to manage multiple VM. Okay, so this will manage all aspect for your guest's OS on your main laptop or workstation. Okay, now so that was the virtualization. If we will move forward, what is containerization? So containerization is same like a virtualization, means it is also like a virtualization technology, but in here there is an infrastructure. Okay, now on the infrastructure you have your own operating system, and now instead of host OS you will run something called container. Okay, now container is a single package of software built using containerization technology is called a container. Okay, the container is a standalone package independent of the host operating system. Being as such, it can then execute across multiple platforms without any issue. Okay, so they don't contain any particular host operating system. They are a set of application which runs on their own. Okay, now for running these so-called containers, it also needs some kind of hypervisor, right? So in here we call something called a container engine. Okay, so if you will use a Docker, now the Docker have a Docker engine for running those container over your main operating system. Okay, now if you will talk about definition, let's move ahead. So when code is developed in a specific computing environment and transferred to a different environment, there is high possibility of the code to result in bugs and error due to missing dependencies, libraries, or any configuration setting files. Okay, so we'll talk about this later also. So containerization is the process of bundling the application code along with libraries, configuration file, and dependencies required for application to cross platform. Okay, containerization is an application packaging approach where the code is written once and capable of executing anywhere, making the application highly portable. Okay, so if you will talk about why do we need containerization, so let's take an example. Okay, now suppose if you want to deploy an application. Okay, so if you want to deploy an application, let's suppose you want to deploy a database called Redis. Okay. Now in virtualization, you will have an infrastructure, an operating system, an hypervisor, and then your host operating system. Okay. Now the host operating system, the ISO images are large, right? They are around 5 to 6 GB if you will talk about the latest operating system, right? Now, suppose you install your host guest operating system on your host machine. Okay, now suppose you want to use your Redis database, right? We will talk about dependencies. You have installed the application and running it. Suddenly you got an error saying that hey, this dependency or library cannot be found, right? Now for that library or dependency, you deploy another virtual machine, right? And then you find out that another piece of dependency is required. So suppose in this you run a Redis image and port is occupied by Redis. Now on the other VM, you are running another set of configuration and you need another host OS. Okay. Now these are taking space, right? 5 GB, 5 GB, 10 GB, and also they are slow to start. Okay. Now, if you will talk about containerization, so they are small piece of code. Basically, the containerization is small piece of app. So what it will do, it will have their own binary and library dependencies, everything else in their container itself. So what you can do in containerization, you can create a container for those specific app like for Redis, for cache, for MongoDB, and you can run them and combine them or orchestrate them. Okay, so that is the main advantage of using containerization. Okay, you don't need to set up your VM. They are just small piece of application you are going to run. They will get start in a bit and you are ready to go. Okay, now let's talk about five key advantage of containerization. So first one is portability. So container can be moved to a different environment without rebuilding the application. Okay, so suppose you package this container and you push to any repository. Now it will not get run only on Windows. So suppose if you have Docker running on Mac OS or Linux or any other flavor of Unix, so what you can do, you can just pull that application from repo and start running it. Okay, scalability. So if you are using any orchestration technology, it will give you feature of scalability. Okay, so with using the same image, you can create multiple container. Okay, now if you will talk about efficiency, so this basically the containers run completely isolated from your host operating system, unlike virtualization. Okay, they don't have any dependency on your host operating system. The only dependency is on they are, which is your container engine. Okay, now agility. So because they are lightweighted, they can be quickly created and deployed in any environment. Okay, and if you will talk about security, so as they are many isolated environment as compared to the virtualization, so they provide complete security. Okay, so you do not need to worry about the security also. Now let's talk about some tools. So if you will talk about virtualization tool, most famous tool for Windows is Hyper-V. So this is the icon for Hyper-V. Okay. Now next one is VMware ESXi. So it is also one of the leading technology for virtualization. So VMware ESXi. Next one is having VMware Fusion. It's an also, but I think it's very kind of old now. Next one is Oracle VirtualBox. So you use this for deploying any virtual machine on your testing environment, or if you want to run any lab, so you can just install VirtualBox. So it will give you various options to customize your VM, right? Unless Microsoft Hyper-V. And next one is having Citrix Sense Server. So basically, you have to purchase a subscription for creating any Citrix virtual environment. Okay. Now, if you will talk about containerization tool, so there are two leading containerization tool available out there. First one is Docker, and another one is Kubernetes by Google. Okay. Now, if you will talk about the main differences between virtualization and containerization, so basically they are most asked question in the DevOps interview. So if you will talk about the first point, so as they are using ISO image, and you might have also seen while starting your host OS, it takes some time, right? So they are very heavyweight, okay? While the container is lightweight, they are just megabytes of code written for app, and they just start in a bit of seconds, okay? Now, the virtualization is like limited performance. Whatever you set or give the resources while creating the VM, it can run up to only till that. Okay. While the container is not limited to that, whatever the application is going to need, it will get run. Okay. Now, whatever the virtualization environment you have created, each VM will have its own VM of gigabytes of size, right? While all container will share your host OS, and they will be connected via Docker engine or any kind of container engine. Okay. Virtualization also called an hardware level virtualization, while the containerization is OS level virtualization. Okay. So as they are heavyweight, so they take minutes to start up, while the container take millisecond to start up. Okay. Now these one are for host operating system, so they have their own operating system, so they will definitely require their own library dependencies of megabytes of size, right? So they allocates memory, and also they require higher RAM to run it, while they don't. Okay. Now they are fully isolated, and basically what it is done, so they are creating their own VM. Okay. So if you talk about more security, so they are considered more secure than container, but yeah, container are also secure. Okay. So basically they are process level isolation. Once the process stop, so they are not being run. Okay. While if the Windows or your host guest OS gets into sleep, so then it is also fully isolated because they are have their own operating system running in the background. Okay. So that was the main key differences between virtualization and containerization, and they also asks many times in the interviews. Okay. So you should be aware of that. So I am hoping you are clear with these two keywords, virtualization and containerization, because you should have a base knowledge about it if you are going in DevOps field. Okay, so I'm hoping you are clear. Now let's move ahead with another keyword. Till then, take care. Hi friends, now you know something about containerization and also the difference between virtualization and containerization and how containerization works under the hood, right? Now let's understand overview of orchestration with the help of containerization. Okay. So suppose if you want to run set of containers together to combine them and build a specific app. Okay, so how you will do that? Suppose if you want to run multiple copy of a task, so how you will do that, or how you will run multiple copy of a container. Okay, so for achieving this, you have a term called orchestration. Okay, so orchestration is combining multiple execution of IT automation tasks or processes to achieve a single individual entity or application. Okay. Orchestration is usually applied across multiple computer system, application, and services to ensure that deployment or configuration management or other processes are performed in proper sequence. Okay. If you will talk about benefits, so The first one is deploy applications more quickly and efficiently, resulting in improved customer experience. Okay, so basically they are mostly used for containerization or small set of apps. So definitely if they are small set or if they are container, they will be deployed quickly. Second one is reduce manual task and basically sorry it will be manual task and processes to focus on more strategic activities. Okay, so you don't need to worry about manage multiple orchestration at the same time or multiple apps at the same time. You can hand over it to orchestration and you can focus on other things on the more hand. Okay, third one is minimize performance issue or outages caused by error or misconfiguration of a system. Okay, so there are various orchestration tools, so they have self-healed properties. Now if you will talk about Kubernetes, so how it is run, suppose if you are set to run 4 containers and one container went down, right? Now what it will do, the Kubernetes will automatically bring back that computer. Okay, so they have self-healed technology inbuilt in them. Okay, fourth one is improve collaboration across multiple IT domains like network security. Okay, so you can combine them with network security. Okay, and also you can combine them with volume and you can map the volume. Okay, also they support various type of network and volume mappings. And fifth one is optimize cost saving by ensuring that systems such as cloud resources are decommissioned during periods of low utilization. Okay, so you can set the alerting system or monitoring system. So suppose if the utilization is not being used, it will automatically delete it, and if they are going to be used, it will automatically bring back those containers. Okay, I am hoping you are clear with the benefits. Now if you will talk about example where the orchestrations are used mostly, so first one is cluster provisioning. So you can use tools for configuration management or infrastructure as a code tools for achieving this. Second one is cloud infrastructure upgrades. You can also achieve this by configuration management. And third one is container deployment and monitoring. Okay, so you can use tools like Docker Compose or Kubernetes for this task. Okay, so I am hoping you have a brief info and brief understanding about orchestration. Okay, now, if you will talk about tool, the first leading tool is Docker Compose. So this is its icon. So Docker Compose is a tool for defining and running multiple container application. Okay, it is the key to unlock a streamlined and efficient developed and deployment experience. Okay, okay. Now the next one is Kubernetes. So this is most demand and most advanced tool. So basically, it is preferred over Docker Compose. So Kubernetes is an open source container which is brought by your Google for automating software development, scaling, and management. Okay, so it also provide many advantage over cloud. So they can be integrated with cloud to provide various feature. Okay, so these were the orchestration tool. If you will talk about another, so you can use Ansible also for orchestrating your IT system like cluster provisioning and other IT processes. Okay, another one is OpenShift, so a container orchestrator that adds platform as a service and GitOps functionality to Kubernetes. Okay, so it can be integrated with Kubernetes and more work as more advanced. And next one is Terraform, so it's an also infrastructure as code tool that enable you to safely and predictably provision and manage infrastructure in any cloud. Okay, so I'm hoping you are clear with orchestration tools also. Now let's move ahead and let's learn about another keyword used in DevOps practice. Okay, so till then, take care. Hi friends, in the previous lecture we have learned about orchestration and some famous orchestration tool and also how orchestration helps in IT world. Okay, now let's move ahead and let's learn about monitoring in DevOps, which is considered as an important aspect in DevOps. Okay, now the DevOps monitoring is the practice of continuously observing and analyzing the performance and health of various components within a software delivery pipeline. Okay, so this phase is very important for deploying or delivering a software to our customer, right? This includes monitoring application. So suppose if you want to see the KPI indexes or performance of application, or whether you have set up any infrastructure behind this, if you want to check how infrastructure is working or how the networking is working, how the load is going in, going out, and also the other services related to it. So you can monitor all of them. Okay. Now the primary goal of DevOps monitoring is to basically we can use continuous monitoring here is to provide real-time insights and feedback that enable team to detect and resolve issue quickly. Okay, that's what is for monitoring. Now next one is types of monitoring in DevOps. So as we have seen here, so you can see any application performance, you can see any infrastructure, you can monitor your infrastructure, you can monitor your networking, how much traffic is going in or going out, and you have also cost monitoring tools, or you can implement cost monitoring also. Okay, now let's move further. Now let's understand factors to consider when choosing a DevOps monitoring tool. Okay, now which tool you should use, so which factor you should consider. So first one is scalability. So when select any monitoring tool, so whether does it give you any scalability feature. Now next one is integration capability. So this is a must, every company search for it. So if your monitoring tool should provide integration capabilities with other cloud resources or cloud technologies. Third one is visualization and reporting. So does your monitoring tool give the reporting in visualization form or aiding form? Okay. Fourth one is alerting and notification. So does your monitoring tool have alerting and notification feature in that? Fifth one is observability and troubleshooting. So does it provide some kind of logs too for your software or for your application? And the sixth part to consider is does this monitoring tool have a cost and licensing model, and whether they are limited to any one cost model. Okay, and last one is of course you need ease of use for selecting any monitoring or DevOps monitoring tool, right? So you have these factors to consider when choosing a DevOps monitoring tool. Okay, now if you will talk about tools, there are various tools. I have categorized some tools in their own category. So let's see some famous tools in DevOps monitoring. So first one, let's first discuss about open source monitoring. So first one is Prometheus. So it's a very famous. So it's an open source monitoring and alerting tool originally built at SoundCloud. Okay. Prometheus is especially well suited for monitoring cloud native containerized environments. So you can integrate with them, or also you can see if they are having any cost model. Okay. It collects metrics from configure target, stores them, and allow query with a flexible query language. Okay, so they supports a query language also, so that you can filter them with a timestamp. Next open source is Nagios. So it's also one of the popular. So it's a pioneering open source monitoring tool that monitors system, applications, services, and business processes. Okay, it watches hosts and services specified using external plugins and alerts when issue arise. Okay, so it's saying that they also having an alerting system in place, while Prometheus also have alerting system in place. Okay. Next one is New Relic. So that's the icon of New Relic. So it's an observability platform that brings together logs, metric events, and traces into one connected experience. So all of having their own feature, and you should check out their pages for finding out which is suitable for your software or for your application. Okay. Next one is your Dynatrace. So basically AI ops intelligent for IT operation is a comprehensive platform. Thus Dynatrace belongs to AI ops that offers end-to-end observability and intelligent automation for modern cloud native application. Okay. Next, if you will talk about application networking and infrastructure monitoring tool, so first one is Splunk. Now, the Splunk is primarily focused on analyzing machine data like application logs, infrastructure logs, IoT data, and more and more. Okay. Next one is Sensu by Sumo Logic. So it's a monitoring event pipeline that enriches data from multiple resources and routes it to handlers of filtering, pre-processing, and escalation. Okay, so they have some kind of pre-processing data in there. They process through it and will give you the event data by them. Okay. Next one is Chaos Search. So basically, it enables log analytics directly on cloud like AWS S3 bucket without needing data movement or transformation. Okay. If you want to looking for data aggregation and cross-domain enriched tools, so you have PlanView Hub, so also known as formerly Task Top Integration Hub. So this provides a model-based integration to connect software delivery tools across the DevOps tool chain. Okay, it enables the syncing of data between DevOps and agile tools. Next one is Big Panda. So you might have heard about it. So it uses event correlation algorithm to automatically aggregate, enrich, and correlate alerts from different infrastructure and application monitoring sources into high-level insights. So basically, they are for big data analytics. So you can integrate with them, and you can get a high-level insights for those data. Next one, if you want to monitor your CI/CD pipelines, so for those also we have some kind of tools in place. So first one is Cisco App Dynamics. So it enables the monitoring of CI/CD pipeline by integrating with the tools like Jenkins. Okay, so Jenkins is a CI/CD pipeline. You can integrate with them. It provides performance feedback across the SDLC using correlated application and infrastructure monitoring data, right? Next one is Jenkins. So you might have heard about it. So this is a CI/CD tool. Of course, they provide a monitoring feature also inbuilt in them. Okay, so they have that. Next one, test server monitoring. So you have Selenium as a leading tool for this. So it's a widely used open source framework for automating web browser. It supports multiple browser and operating system, enabling developer to write a script in various programming language such as Java, C Sharp, and Python. Okay. If you need any alarm aggregation and incident management, then you have PagerDuty in there. Okay, so it's a leading incident management platform that integrates with various monitoring tools to provide alerting, on call scheduling, escalation policies, and incident resolution. Okay, so I am hoping you are clear with the various tools categorized in various category. Okay, so we have discussed about only few of the monitoring tools. There are many tools out there for your monitoring. So while selecting our DevOps monitoring tool, consider for your factors, okay, and select the best tools for you. So I'm hoping you are clear with the monitoring tools in DevOps. So let's meet in the next section with microservices and monolithic services. Okay. So till then, take care. Hi friends, in the previous lecture we have seen about different types of monitoring tools in DevOps and how and which factor you should consider while selecting any monitoring tool in DevOps for your software or for your application, right? Now in this lecture let's discuss about one important aspect in DevOps which is microservices. Okay? Now, this is the most asked question in DevOps interview. What are microservices? And also, it is asked with monolithic architecture. Okay, so what's the key differences between them? So let's understand it. Okay, so if you will talk about an overview, so a monolithic application is built as single unified unit. Okay, so as the name suggests, mono, right? While a microservices architecture is a collection of smaller micro. Okay, independent deployable services. Okay, so you want to select which one is right for you, so it depends on number of factor. So we will see about that, and also we will see about what are advantages and disadvantages under these architectures, right? Now, let's first understand monolithic architecture. So, suppose there are three services you can provide over your application. So, there is payment, then shopping cart, and there is an inventory. Okay, there are three sub services for your application. Now, in monolithic, what you are doing, you are connecting all these three to a single instance. Okay, so what is the single instance? Whatever you are managing, deploying, everything is managed by a single instance. And whenever the users are or your clients are connecting to any of the services, it is redirecting to the services via this single instance. Okay, so that's called monolithic. Now let's go over it and let's understand in depth. So, a monolithic architecture is a traditional model of a software program which is built as a unified unit that is self-contained and independent from other application. Okay, so basically what it will do, it will bundle a set of services in the single instance. The word monolith is often attributed to something large and glacial, which isn't far from the truth of a monolith architecture for a software design. Okay, a monolithic architecture is a singular large computer network with one code base that couples all of the business concerns together. Okay, so it's combining all the software or all the piece of code, all the business concerns that are in different departments, it combining all of them. To make a change to this sort of application requires updating the entire stack. Okay, so we'll discuss about this in advantages or disadvantages also. Okay, so updates are restrictive and time consuming. So let's understand with the help of advantages. So first advantage is easy deployment. So of course they are just single entity, so they are easy to deployment. Development is so also easy. Now if we'll talk about performance, so they may form faster because all of them are considered as a single entity and all the services are running in a single entity. Now, if you will talk about simplified unit, so you need that one simply unified unit for testing it, right? Now, as monolithic is unified unit, so it is easy in debugging. Okay. Now, here we have discussed that it's easy in development, but the development speed is slower because you need to combine all the microservices to a monolithic services. Okay, we'll discuss about microservices. So basically what it is happening here, so you are creating several services by their side and you are combining them to a unified unit. Okay, so it's making a development speed slower. Now scalability, so as you have combined them a unified unit for some of your sub services, so it does not give functionality of scalability after developed or after deployment. Okay, also you cannot be reliable because they are limited to only some services. Next one is barrier to technology adoption. So once the technology are fixed to those deployment, you cannot change that. Lack of flexibility. So you might have get that. Okay. And then you have deployment. So if you want to redeploy it, you cannot. Okay. So they will cause the issue in redeployment. How? So suppose if you are changing one piece of service, okay, so there are multiple service combined as a unified unit, and suppose if you want to change only one of the service, so what it will do, it will need change of the whole three service together and it will change the whole unified unit. Okay, so that's what make redeployment bit disadvantageous in monolithic. Okay, now, on the other hand, if you will talk about microservices, so suppose there are three sub-services in here, so payment, shopping, and inventory. So they are also connected with each other. Okay, and also each of them are having their own services in place. Okay, so they will be have their own services in place. They will be managed. So it's called a UI microservice basically, which will manage every of them individually, and then it will whenever the client will make connection, it will get connected to their particular microservices for the sub services. Okay, now let's understand a microservices architecture, also known as microservices in as architectural method that relies on a series of independently deployable services. Okay, these services have their own business logic and database with a specific goal. Updating, testing, deployment, and scaling occurs with each service. Okay, you cannot do that with the same service like unified unit, like same like a monolithic, right? So in here it goes different. Microservices decouples major services domain specific concern into separate independently code bases. Microservices don't reduce complexity, but they make any complexity visible and more manageable by separating tasks into smaller processes that function independently of each other and contribute to the overall whole. Okay, so I'm hoping you are clear with the basic definition. Now let's talk about advantage and disadvantage. Okay, so if you will talk about advantage, so there are various advantage for using microservices. Okay, and in DevOps we prefer microservices architecture mostly. First one is agility. So definitely they give faster and reliable products in there. Now you have flexible scaling. So if you want to scale any particular service, you can do that. Okay. Now they provide and feature of continuous deployment too. So whatever microservices or any particular services you are handling with, you can make them redeployment. Okay, highly maintainable and testable, so they are highly maintainable. Okay, now as they are individual services, so they are independently deployable. Now as these are advanced architecture, these microservices, so they have now functions to collaborate or integrate with IT technologies. Okay, and they are higher reliability, and as they are having different type of organization entity separated, so there are happier teams in between them, there are no dependency in between them. Okay, now if you will talk about disadvantage, there are disadvantages also. So first one is development sprawl, so there are many development complexion in between them. Okay, exponential infrastructure costs, so if they are being deployed on different infrastructure or different services by separating their management, so of course they will cost more than the monolithic. Okay, also it will add an organizational overhead. You might have debugging challenges, so you need to look for every services separately. They might not have a lack of standardization because you are managing your all microservices individually. Okay, and also lack of clear ownership. Okay, so whatever the services, so suppose if the services are going to attach or integrate with any particular high level software or application, so there will be not clear that which microservices causes the issue. Okay, or which microservices causes the downtime of that particular or main application. Okay, now I am hoping you are clear with microservices and monolithic architecture, and we have also discussed about the advantages and disadvantages for these. Okay, so let's meet in the next section with new keyword in DevOps. Till then, take care. Hi friends, in the previous chapter you have learned about microservices and monolithic architectures, and also how they helps in different categories of IT, and also we have discussed about advantage and disadvantage under these services or architectures, right? Now let's move ahead and let's discuss about one important aspect in DevOps and cloud. Okay, so how these things are related to each other, whether they are independent or they are dependent of each other. Okay, so let's discuss in this lecture. Okay, so if you will talk about DevOps, so DevOps can be considered as a set of practice, tools, and philosophy. So we have discussed it. That is used to automate and integrate the process between software development and IT teams. Okay, so this helps in improving the product quality and accelerate time in market. So for faster and reliable product, we prefer DevOps practice. Okay. Now, on the other hand, the cloud is basically allows for simultaneous development to occur, enabling continuous collaboration between different teams across globe. Okay, when DevOps and cloud solution work together in an environment that is built for flexibility and agility, okay, and it can be also termed as cloud DevOps. So this term is also asked sometimes in interview, what is cloud DevOps? Okay, so if DevOps and cloud is going to work together, that are called cloud DevOps. Now, how do DevOps and cloud works together? Okay, so if you will talk about how these things are work together, so first one is cloud is leveraged by DevOps. Okay, so basically organization utilizing DevOps manage and automate their infrastructure using cloud computing technology. So there are various cloud computing technologies they are using it. Okay, so what it enables, so these enable them to follow an agile approach to different work processes in there. Okay, so if you will talk about, let's for instance, if an organization needs to start building on new software or project or scale up an existing production application, it can cause needless delays and complexity for DevOps team. Okay, so basically in cases like those, infrastructure offers an important boost for DevOps. So basically, it can minimize the latency and enables a centralized management via a unified platform. Okay, so in that case, you don't need to go here and there and search for different types of tool. You can just go and sign up for any particular cloud, and it will do that. Next one is cloud SecOps, means cloud security operations. So it's a collaboration between IT security and IT operations. Okay. So it's nothing but it just integrates processes, tools, and technology to keep an enterprise secure along with reducing any associated risk. Okay. And if you will talk about DevOps as a service, so basically is a set of cloud-based tool that enables collaboration between the development and organization teams of an organization. Okay, so many cloud providers will provide these as a service. Now we have discussed this, so the world's leading cloud providers like AWS, Azure, and Google are excellent cloud DevOps tools. They provide a number of DevOps as a service offering. Okay, so if you need to deploy any software, you don't need to go here and there and searching for the tools and how you can use them. So the cloud providers have their own DevOps as a service things built in place where you can also learn about them, see the demos about them, and start using them. Okay, definitely you need some kind of licensing for using them. Now, this makes a DevOps and cloud a best friend so that you don't need to go here and there and searching for the tools. Okay, now let's discuss about some tools built in some of these advanced cloud technologies. Okay, now if you'll talk about AWS, so AWS provide AWS code pipeline. So basically it build, test, and deploy code every time there is a code change based on the predefined release workflow model. Okay, next one is code build. So it basically compiles the source code, runs the test, and generates ready to deploy software packages. Okay, if we'll talk about code deploy, so it automates code deployment into any instance. Okay, including on-premise servers, AWS EC2, AWS Lambda, etc. If you will talk about AWS Code Star, so it's basically helps in quickly developing, building, and deploying application on AWS. Okay, basically it's a unified user interface that enables one to easy manage software development activities in one place. And if you will talk about code commit, so it's like a git, so you can consider this as a private git repo. Okay, now if you'll talk about Azure, so these all of these are very popular. First one is Azure pipeline. So this build and test project code automatically. Okay, it utilizes CI/CD while building, testing, and shipping the code to the respective environment of your choice. Okay, next one is Azure boards, similar like a Kanban board. You might have heard about it. So it basically provides interactive and customizable tool for managing software project. Okay, And it also provide variety of capabilities including calendar view, native support of Scrum, Kanban, and agile processes, reporting, and configuration dashboard. If you will talk about repos, so there are also most important. It seem like AWS code commit, so they works like a Git. Okay. Next one is test plans. So basically, they provide tools for driving quality and collaboration across the SDLC, right? And next one is Azure artifacts. So basically, they manages the dependencies used in the source code. Okay. So similarly, like artifact for your operating system or for any application, these are the Azure artifact. They are stored in there. They are predefined in there. You just pick them and use them. And also, they basically the artifact supports a range of package types such as npm, NuGet, Python, and many universal packages. Okay. If you So if you will talk about Google DevOps tools, so first one is Google Cloud Build. So it executes the project builds on Google Cloud Platform infrastructure. Okay, it can import source code from Google Cloud Storage, Cloud Source Repository, or GitHub or itself. Execute build as per the required specification. Okay, next one is Cloud Google Cloud Deploy. So basically, it automates application delivery to a series of target environment in a defined promotion sequence. Okay, similarly, like Azure pipeline. Next one is artifact registry. So basically, it's centrally manages artifact and dependencies. It provides simple integration with existing CI/CD tools so that automate pipelines can be set up. And next one is cloud monitoring. So basically, it will connect your metrics, events, and metadata from various sources, including your uh, different technologies also. Okay, so I'm hoping you are clear with these cloud leading tools which provide DevOps as a service. Okay, now let's meet in the next section and let's discuss about some important keyword used in DevOps and also we'll discuss about them in one line. Okay, so basically it will help you in covering your DevOps interview. Okay, so let's meet in the next section. Hi friends, so in this lecture let's learn about some DevOps terminologies which is mostly asked while having an interview or if you are going to become a DevOps engineer, you should be aware of this term. So we have some terms in there. Let's discuss about them. So first one is A/B testing. So basically you can see in here also A/B means it's comparing, right? So it's a testing technique that compares user behavior and metrics to different feature variant to evaluate which version is performing better. Okay, so basically this testing is for comparison. Okay, next one is acceptable testing, also called UAT. You might have heard about it. So it determines if a system meets business requirement, user needs, and authorized entity benchmark. Okay, so acceptance testing is repeated whenever there is new application development. Okay, next one is agile. So this one is important term. So it helps manage complex operation and basically we can also say that it's an approach that focuses on customer feedback, collaboration, and rapid and small releases. Okay, so everything will be released in smaller sprints. Next one is application release orchestration. So we have already discussed this orchestration. So DevOps team leverage application release orchestration tool to manage application release processes. These tools provide a complete view and of the application release pipeline. Okay, next one is behavior driven development. Okay, BDD. So it can help establish a standardized communication between development team and project owner. Okay, so proper implementation of BDD can prevent misunderstanding and social frictions. Next one is black box testing. So a test this is a testing technique that emphasizes on functionality of an application under test AUT without considering implementation details, the internal structure of code, or the internal software path. Let's move ahead. Next one is blueprint. So DevOps blueprint incorporates CCM, continuous change management, CT, continuous test, CI, continuous integration, and CD, continuous delivery capabilities with the automation of every operation needed for fast-paced production development. Okay. Next one is build artifact repository. So the build artifact repository manages the entire artifact lifecycle, providing support to various software management system while ensuring consistent to CI/CD or CD workflow. Okay. Here CI/CD we know, CT means continuous test. Next one is build automation. We have discussed about this in a separate lecture. So basically it involves processing of automating software code, retrieval from a repository, building it, testing it. Okay. Next one is canary release. So this one is also frequently asked questions. So basically it's a technique used to lower the risk of introducing new version of software in development by rolling out small changes to user subset before rolling the entire software out to the infrastructure. So what it will do, if there are new version of a software, it will first release to a set of a user, and once it is approved or once it is receive a good feedback, it will then release to the whole infrastructure. Okay, that's called a canary release. Next one is configuration drift. So a phenomenon where hardware and software configuration tends to drift over time, becoming inconsistent because of manual updates, general entropy, and ad hoc changes. Okay, ad hoc means cloud changes, kind of. Next one, configuration management. So we have also discussed about it in our separate lecture. So a process that ensures the maintenance and consistent functional abilities of servers, computer system, and software. Okay. And next one is container. We have also discussed about it. So a container refers to a software unit that package code and other dependencies to make an application run reliably and quickly across different computer environment. Okay. Continuous delivery, we have also discussed about it. So it's an ongoing DevOps practice of testing, building, and delivering user environment and software code improvement using automated tools. Okay. So and what is the difference between delivery and deployment? Deployment is automated process, means while deploying the software it's auto approved, but the delivery there is a manual intervention is required. Okay. Continuous integration, so a software development methodologies where developer merges code changes regularly into a single repository, following which automated tests are and builds are run. Okay. Next one is dark launch, the launching process of production ready functionalities to user subset prior to full launching. Okay. This decouples releases from deployment, enabling DevOps team to get user feedback, perform bug test, and access infrastructure performance. So kind of canary release. Okay. Next one is DevOps intelligence. So basically it correlates and analyzes data from every tool in the software delivery process, offering actionable insights for faster, better, and customer focused delivery. DevSecOps, we have also discussed this, short for development, security, and operation. DevSecOps make all stakeholders accountable for ensuring security with the objective of deploying security policies at the same speed and scale as operations and development decisions. Okay. Next one is everything as code term. So the concept behind this term is that security, operation, infrastructure, and compliance monitoring are treated as an application code so that everything follows the same development practices. Next one is feedback loop. So we have also discussed it while discussing CI/CD. So it's a relationship between the entities where changes in an entity causes changes in another entity, which eventually leads to change in the first entity. Okay, and then it will start the loops again. Now functional testing, a series of processes to ensure that all software components are functioning properly. Okay, so functional testing gives priority to interface testing to check whether user requirements are being met correctly or not. So these can be limited to any specific functions also. Okay, they don't need to be run on a specific application or the whole application. Next one is hybrid cloud. So basically you are combining here both private and public cloud. So you can go through the definition. Next one is infrastructure as a service. So basically if you deploy any VM on a cloud, you are using infrastructure as a service by the cloud provider. Okay. So basically you will lease or take a rent for server for storage. So you are managing every aspect from OS level and the top, and all the backend level is managing by your cloud provider. Okay. Next one is infrastructure as a code. We have discussed it. So basically it applies to infrastructure management, including connection topology, load balancing, virtual machine, and a network. Okay. So you can deploy many set of cloud technologies at the same time by using orchestration and by using playbook tools by Ansible. Okay. Next one is Jenkins. We have discussed about this tool. It's a CI tool. So it's an open source tool for automation. Jenkins scripted in Java and includes variety of plugins for CI. Okay. Next one is Kubernetes. We have also discussed it. It's an containerization orchestration tool developed by Google, and Kubernetes makes managing and deployment distributed system easier for Linux developers. Next one is microservices. We have just discussed it in our previous lecture. So it categorizes the architectural model of developing distributed application from discretely deployable services that carry out specific functions. Okay. Next one is non-functional requirements. So basically they specify system attributes including usability, scalability, maintainability, performance, security, and reliability. Okay. Next one is platform as a service. So suppose if you are using a database via any cloud provider, you are using platform as a service. Okay. So it's a cloud computing category that offers a platform to developer, allowing them to build, manage, and run application. Okay. Now the level till OS and below means the infrastructure and all. So that is managed by your cloud provider, and all above other than OS level and inside that you are managing that. Okay. So that's called platform as a service. Product owner. So it's a crucial leadership role which is responsible for managing the complete product lifecycle from beginning to the end. Next one is regression testing. It's also one of the frequently asked questions. So testing that reviews issue introduced by fresh updates and addition to the code database. Okay. Regression testing is done to identify new bugs caused by updates. Next one is release management. So it's about controlling, planning, and scheduling the development and delivery of a software. Now, what is software chain of custody? So, in software development, the chain of custody refers to having full knowledge and understanding of the release status at any point in time. Next one is TDD, test driven development. So, it's a process in software development that uses a short feedback loop where developers create tests that fail immediately and then they write the code to quickly pass the test. Next one is tool chain. So it's a combination of DevOps tool that help in development, management, and delivery of application across the entire development lifecycle. Next one is unit testing. So it's about testing a single functionality pieces in isolation. Value stream mapping is a visual representation that uses key metrics to measure and evaluate success. It helps developers improve continuously. Next one is virtualization. We have seen that the virtualization and containerization, right? So basically it allows DevOps team to test, develop and run application on a live and virtual environment. Okay. This facilitates development alongside testing in real time. Waterfall, a linear approach or a traditional approach in software development. Okay. And the next phase cannot start until the previous phase is over. So it was a traditional method. We might have also heard about it. Next one is white box testing, also called glass box testing. So it basically tests the internal design structure and component of a software. Next one is zero tolerance. So in zero tolerance for a service interruption of a failure. So interruption or failure of any kind can have a devastating impact on an organization. That is why there has to be a zero tolerance approach to the distribution. Okay, there are various practices following within this practice. Okay, I am hoping that it will help you for mastering your DevOps interview. Okay, so now we have reached at the end of the course, and thank you all for joining me. And this course will be very helpful for setting up your journey in DevOps. Okay, so if you like my lectures and if you like my sharing, please go and subscribe my channel and also like and share it with your friends who want to start their journey with DevOps. Okay, so I'm hoping we are clear with all the aspect of DevOps and you are ready to gear into the DevOps world. Okay, so let's meet in the next lecture of the series. Till then, take care everyone.